Air traffic control using distance, rate, and time to coordinate airplanes. Alright, for these problems you only have these options for speed. You cannot choose anything else. That's part of the problem. So here's the very basic example that you can have. You have an airplane here, which I just happened to steal Air Force One, so we'll use that. And we're going to put this one here. The nose of the airplane rests on where it's actually at. That one is 110. This one is going to rest here at 90. Each plane is going to start with an initial speed. So for the first one up here, there are two Air Force One planes, so we're just going to call this 1, and we're going to call that one 2. The speed for the top one is going to be 360 miles per hour. The speed for the bottom one is going to be 260 miles per hour. Basic calculations. How long is it going to take for airplane 1 to make it to there? What do we know about that one? What information can you get from airplane 1 from what's on the screen? It's 360 miles per hour. What distance is it going to travel? It's going to go 70 miles, yep. So there's 70. And the time that it's going to take to make that trip, that distance, is t. We don't know what it is, but we have to solve for it. How do you solve this equation? Divide both sides by 360. Which means these cancel out. And you're left with 70 over 360 equals t. If I do 70 divided by 360, what decimal do I get back? 0.19, and then the 4 is repeating. What unit is time in? It is not in seconds. It's in an hour, yes. Time is in terms of an hour because 360 is what units? Miles per hour, so the time has to match up. It's in hours. 70 over 360, we divided that and got 0.19, and then the 4 repeats. To turn that into minutes, what would I do to that decimal? It's in hours now. What do I do to turn it into minutes? Multiply it by 60. So times 60 is going to be 11 2/3 minutes. 11.6 repeating is 11 2/3 minutes. Airplane number 2 is going 260 miles per hour. We want to see how long it's going to take it to get to that same point. What information do we know about airplane 2? Where does the 260 go?
On the right.
On the right. 260 miles per hour. How far is it going to travel?
90 miles.
How far?
90.
90 miles.
50.
1, 2, 3, 4, 5. It's going to go 50 miles. Where does the t go? By the 260. What do we do to solve for t? Divide both sides by 260. Divided by 260. 0.1923076,923, but what do I do to make it minutes? Times it by 60. And we come out with 11 point, and we'll make it 54. 11.54 minutes. So if these planes are both traveling at the same time, one is doing 360, the other one is doing 260. The first one is traveling 70 miles. Second one is traveling 50 miles. Which plane is going to make it to that mark first? Which plane is making it to this mark first?
Airplane 1.
Airplane 1 is 11 2/3. What is 2/3 as a decimal? 0.6 repeating, and we have 0.54. This one is going to get there before this one because this time is less. So airplane 2 makes it here first, but where is airplane 1 when airplane 2 makes it to this spot? How long did it take airplane 2 to get to this spot?
11.54 minutes.
11.54 minutes. So we have to figure out where airplane 1 is at 11.54 minutes. We know that airplane 2 is going to be there. How are we going to figure out where airplane 1 is at 11.54 minutes?
Do you subtract the times?
Nope, we got to find the distance. Do we have a formula for finding distance? So the distance is what we're looking for. What is the rate that plane 1 is flying at? 360 miles per hour. How long is plane 1 going to be flying in this scenario? That's how long plane 1 took to get to its mark. But we want to find out where plane 1 is at when plane 2 reaches its mark, the red one. Plane 2 took 11.54 minutes to get to that red mark. We want to find out where plane 1 is at in 11.54 minutes. Wouldn't we not put this time here? What unit does that time have to be in? It's got to be hours because this is 360 miles per hour. Do we already have a fraction in the plane 2 work down here that has the time in terms of hours? 50 over 260. Yep. So if we put in 50 over 260 here, we can figure out where plane 1 would be at. 50 divided by 260. And what would I multiply that by? 360. That would be 69.23. What is 69.23? What units is that?
Minutes.
It's not minutes.
Hours.
It's not hours. What does D stand for?
Miles.
It's in miles, yes. So we go back up there to plane 1 and we mark it off. 1, 2, 3, 4, 5, 6, and 69.23 would be just shy of that mark. So it is a close call as to who gets there first. In this problem, UA 1989 is traveling 480 miles per hour. We want to see how long it's going to take that plane to reach this. And then AWE 2325 is traveling at 420 miles per hour. We want to see how long it's going to take it to reach that point as well. For UA 1989, what information do I know that I can plug in? It's going 480 miles per hour, so we'll put that here. What else do we know?
It's going 110 miles.
110 miles. So we're going to look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is 110 miles. Time goes here. To solve for t, what do I have to do?
Divide both sides by 480.
Yeah, divide by 480. So we have 110 over 480. And we'll set that equal to t. 110 over 480. What do I do to change that to minutes? Times it by 60, or if I wanted to, I could leave it as 0.2291, maybe round it to the third decimal place, maybe the second, maybe the fourth. But if we want to put it in terms of minutes, we can do times 60 and come up with 13.75. 13.75 minutes to go 110 miles. What about AWE 2325? What do I know about that?
It's going 420 miles per hour.
420 miles per hour. How far is it going to travel?
90 miles.
90 miles. What do I do to solve for t?
Divide both sides by 420.
Divide by 420. 90 over 420. And then multiply by what?
60
And that gives me what units?
minutes.
Minutes. 12.86. 12.86 minutes. Which aircraft makes it to the blue mark first?
AWE 2325.
That's right. AWE 2325 makes it there first. Remember, you only have 6 speed options, so the next question coming up is, what is the lowest speed at which UA 1989 could overtake AWE 2325? In other words, make it to the blue mark before that. You could say you could up the speed of the plane to 700. It's not even on our speed option, but it would definitely overtake it. But you don't want the plane going as faster than what it has to. It burns up a lot of fuel. So it's going at 480 right now. How many speed options do we have above 480? We have one. So does that mean the answer is automatically 520? Would it be possible if we went to 520 miles per hour for the UA 1989 that it may still not overtake the second plane? Is that possible? Let's find out if it would get there before that. How am I going to figure out if 520 miles per hour would make that plane get to the blue mark first? What would I do with 520 miles per hour? We could plug it into the formula. So we'll come over here to this side, and 520 miles per hour. Okay, well, what else do I have to put in here? what distance is it traveling?
110 miles.
The top one is traveling 110 miles, so we'll go 110. And the time is what we're looking for, because if that time ends up being less than 12.86, that means that that plane would have made it there first. So we will do 110 divided by 520. And then multiply by 60. What do we come up with?
12.7.
To two decimal places. 12.69 minutes. Okay, with that in mind, is 12.69 minutes less than 12.86 minutes?
Yes.
Yes, so the answer would be 520 miles. Would get that top plane there first. That is its maximum speed according to our speed options that we were given. So it would get there sooner. For this problem, we want to see what the distance is going to be between the planes when one of them makes it to that blue mark first. Those planes are not traveling at the same speed. You have 360 and 420. One of those planes is going to make it to that blue mark first. Which plane is that going to be? The bottom one. It's going faster. They're both starting at the same spot, and they're both having to end at the same spot. What is going to be the difference in the distance? In other words, once this plane makes it to here, where will this plane be at? Back in here somewhere. What is the distance? The difference between where those planes are at that time. On the top one, how far are we traveling? 1, 2, 3, 4, 5, 6, 7, 8. It is going to be 80 miles at 360 miles per hour. So we do 80 divided by 360. And we multiply it by 60. We come up with 13 1/3. And down here on the bottom, this one is also traveling 80 miles at 420 miles per hour. So we would do 80 over 420. And then multiply by 60. 11.43. So as we predicted, the bottom one's going to get there sooner, 11.43 minutes. But now we want to figure out where the top plane is at when the bottom plane reaches this mark here. How do I figure that out? Distance formula, and what distance would I use? What are we looking for? We're looking for distance. What speed am I going to use?
360.
We're going to use 360, so we'll start with 360. What time am I going to use? 11.43, and we want to use the most accurate thing. So instead of 11.43, what do we use? What's equivalent? 80 over 420. So we use the time of 80 over 420. That'll give us the distance we're looking for. So do 80 divided by 420, and then multiply by 360. And what do we come up with?
68.57.
68.57. What units is that?
Miles.
Miles. 68.57. So this one, when it reaches this blue mark here, it's at 80 miles. And this other one would be at 68.57. How much further ahead is the bottom aircraft? What do I do? What operation do I do? Subtraction. And when I subtract, what do I get? 11.43. What units is that? Miles. Yes. That's what we come up with. 11.43 miles would be the distance. How much further ahead the bottom airplane is than the other one. After your quiz tomorrow over the basic stuff that we did today, you're going to have this added requirement in on your plane problems. No aircraft may be within 10 miles of any other aircraft. And here is your grid. There are traffic patterns on here. There are highways in the sky just like there are on the ground. There are maps of these highways in the sky. Planes, that's why when you look up, you see planes flying the same route every other day. They're doing it the same direction, same from northwest, southeast, whichever. You can spot a pattern if you watch them enough. And here is the pattern that you're going to be given. All of these abbreviations up there, such as NP, T, LGR, those are all points at which you can make a turn and go somewhere else if needed. It's just the route pattern. So that we're going to have problems such that you have an airplane there. You have one here. Maybe one back here. Maybe one there. And another one here. These will all have names, but for right now we'll just make this one 1, 2, 3, 4, and 5. And you're going to be given the order at which these planes are going to approach an airport. And if that were the case, if this were plane 1, if I can get that one to come undone, it will not. So we'll just leave it where it's at. And we'll just use these blue lines. If number 1 had to be out in front, you have to pick the route. You would have to name GTB, LGR, NTP. That's the route it would take. And if this has got to be the second plane, then you would have to slow this one down enough that this one could get out in front of it and fall into line behind that one. If it's not possible, then you have to do the next possible order. Whatever order this one would have to be in, it falls into line, and you have to pick the speed of the 6 different options that were given that would allow that plane to fall into line. If it's not possible, then you make other arrangements. You can choose routes like this, whatever is needed. You just can't go in reverse. Everything's got to keep moving forward and making a turn. That's coming up soon, but until then, you're just going to be starting out with basic problems like this. Here, and then here. 2 airplanes. They've all got to head out to this direction here. That's where they're all going, towards an airport. Therefore, are you going to move this one down to here and then out that way? Does that have to be plane 1? If it doesn't have to be first, then what speed are you going to put this at to make it go there? Does this one need to go this route, or does it need to go this route? With only 2 airplanes, it's very easy. You have multiple options. There's more than one right answer for a lot of these.